Hello students, welcome back. We went through one example problem on hypothesis testing with z-distribution with the probability value approach. That's probably not enough, so let's do another. Here's a nice problem. Please stop the playback and go through. Now, does everybody recognize this problem? It came from this problem here, and we went through this already. Here's a conclusion. So here, even though the average birth weight of all babies in the United States is about 3,300 grams, that's given there, but that's not really the null value because our interest here is for this question, babies born to poor women. So let's restrict our attention to babies born out of poverty and concentrate upon the next part of the sentence. The birth weight for the babies of women living in poverty averages about 2,800 grams with a standard deviation of 500 grams. So we get the null value of 2,800. Moreover, we get the standard deviation of 500 grams as sigma, the population standard deviation. Why population standard deviation? Why not sample standard deviation? That's because this 500 came with the null. Null, what do you mean by null? Nothing. You did nothing, none. You did not do any sample study. So this number came with a population. This problem did not specify population standard deviation of 500 grams. No problem will ever do that. You have to figure it out. For instance, instead of this one being here, if it had been placed in some other place, like here, 20 randomly selected babies, and the mean was 3,060 grams, and the standard deviation was something like this right here, where my mouse is, then this would have been sample standard deviation. But that is not the case here. It came along with the null. So this is sigma, the population standard deviation. So the conclusion, we have to use z-curve, and we have to use sigma. Okay, now let's get the problem done using the probability value method. Here's the setup, we discussed it, and now here's the initial picture, but let me walk through with this. Okay, first the initial picture, the outline, in the center, that is the null of 2,800. And then we are looking for probability that you end up with 3060 or more simply by a sheer log. 3060. So that's a sample mean. And this probability here, that is the question. Now, how do you find this probability? That's not too bad. This is a normal curve. And z-score, you know the z-score, n minus n2 over SC. So you can do that. And then that's going to give you the left-hand side shading, so subtract from 1. Everybody should know this. That's the z-curve problem. Now, after finding out this p-value, this probability, what's next? That's the hard part. What's next? That's the hard part. It turns out, come on, it turns out if p is less than alpha, then HA, and p is greater than alpha, then H0. It'll turn out that way. So probability that you end up with this or higher, assuming that null is right, that means there's significant probability you're going to get a value this bad or even worse simply by luck. And that'll translate into higher probability for type 1 error. And if that exceeds the maximum allowed type 1 error of alpha, then no good. So you'll have to go to the null hypothesis. Otherwise, if p is small, then you go to alternative hypothesis. That's the idea. Difficult to understand, yes, I admit, but that's the method here. All right, let's go back to this notebook. And here's the initial picture, much better picture. 2800 is the null, 3060, and probability for getting something worse than 36 simply by luck. Well, we find out through the z-score computation and minus n2 over sc, and if you do it right, you're going to get about 2.33, and look up 2.33 from your z-table and get your p-value. You're going to get this part, blue part, because shading to the left, and that's about 99%, so you're going to get about 1%, 0.01, certainly less than 0.05, but then again, what does that mean? P is less than alpha, what does that mean? P is greater than alpha, what does that mean? Roughly speaking, this probability value P is more or less the probability that the null is right. Under a certain condition, I have to say. But then again, if I write like this is not roughly speaking, so let's go back. Roughly speaking, P goes hand in hand with the probability that the null is right. So big P, then it's more likely that null is right. So you go with null. Small p, then it's likely that null is wrong. So you go with alternative. That's a bit easier way to understand. Not a correct way to understand. All right, theoretically this is not correct, but it's an easy way to understand. So indeed, you end up with this conclusion here. P is less than alpha, so we reject the null hypothesis and accept the alternative hypothesis. That's how the probability value approach works.